So today we're going to cover section 5.7. We're going to graph systems of inequalities on a coordinate plane. So this is the first day of section 5.7. So if you look at this picture, the pictures of the categorization page, so you can see that some of them have 2 lines on them. Some of them only have 1 line on them, but every one of them has shading. So if I were going to categorize these, I think I would put the ones that had 2 lines together and the ones that have 1 line together. So these over here would be like 5.6, what we did last week, because there's just 1 line with shading. And these over here would be like 5.7, systems of inequalities. So there's 2 lines and 2 shadings, and where the shading overlap is the answer. Okay, and over here, this is just a system or a graphing inequality, so there's just the 1 shading because there's 1 line. So I think that's how I would sort them. So if I determine that if 0, 0 is a system to the solution and I have the actual picture already, I just plot the 0, 0. So if 0, 0 is right here, the solution is up here where it's darker shading. So this is the only part of the solution that's true. So 0, 0 would be no, because although it's shaded here on this side of this line, it's not shaded up at the top where there's dark shading. So the solution to the system is where it's dark shaded. So 1, 2 would be here, so that's no. 3, 8 would be up here next to the T, so that's yes. And then -5, -9's down here somewhere, and that's also no. So the only one that is part of the solution is the 3, 8, because it's in the dark part of the shading where there's double shading. All right, so remember that this one is less than, and this inequality symbol is greater than. This is greater than or equal to, and this is less than or equal to. All right, so the first few on your homework are like this. So you have to determine whether the ordered pair is a solution or is in the double shading for those 2 inequalities. So we're looking for yes or no as our answer. So if this one's X and this one's Y, we have to plug them in since I don't have the picture. So the 3 is going to go right there and the 1's going to go right there. So 1 is greater than 3 minus 4. 1 is greater than -1. That one's a yes. 1 is bigger than -1. Then if I do the same thing over here, and I take 3, 1 and put them in here, so 3 plus 2 times 1 is greater than 5. So that's 5 is greater than 5. That's false. So this would be a no, because in order to pick yes, they both have to work. They both have to be a yes in order for you to choose yes. That one, only one of them is. Okay, so over here it says, Charlie says -2, 0 is a solution to the system. Is he correct? And explain. So this is error analysis. So let's look. So this is X and this is Y. So we're plugging them in. 0 is less than 2 times -2. Well, that's -4. So that one's a yes. And if we plug them in here, 3 times -2 minus 0 is less than or equal to -4. So that's -6 is less than or equal to -4. They're both yeses, so Charlie's right. It's a yes. And again, what it means visually is if I graphed the inequalities, I would be looking at the double shading, and the double shading, -2, 0, would be included in that double shading. On this one, when I graphed them, the 3, 1 would not be included. It'd be included in this shading, but not included in the second inequality. All right, so I have one more. Please press pause and give this one a try. So you're going to try the -2, 3 into both of these. And if they're both yes, you pick yes. If either of them are no, you pick no. All right, so we have 3 is greater than 3 times -2 minus 2. This one was X, this one was Y. I just put them in their appropriate spots. So that would be -8. 3 is greater than -8. That's true. 3 is greater than -8. And then if I do the same thing over here, 2 times 3 minus -2 is less than or equal to 6. So that's 6 plus 2 is less than or equal to 6. That's false. So that's a no. So this is a no. So it would be the point, negative 2, 3 would be in this guy's shading, this inequality shading, but would not be in this part. So it would only be in a single shading instead of a double shading. All right, so if we solve the system by graphing, we have to graph both of them using slope-intercept form. So my slope here would be 2, or 2 over 1, and my b would be negative 1. So I'm going to go down 1 and put my dot, and then up 2, right 1. And I'm going to keep doing it all the way across the screen. It's in the way. Let's see. I'm going to use my line function to go all the way across, just like I would in Desmos. And it is a solid line. And it's a solid line because it has the equal to part. So actually, let me extend that a little further. I want it to go all the way across. And I'm going to put some arrows on there. So it's solid because it has the equal to. And then the shading, what I would do is I would use the origin as the test. So I'm going to take 0, 0 and put it in here. So 0 is greater than or equal. This always cancels out, negative 1. 0 is greater than or equal to negative 1. That's true. So that means this point is true. And I shade the true side. So I'm going to use the highlighter to do that. All right, now I'm going to do the exact same thing with the other line. And I'm going to do it on the same graph, and where the double shading is the answer. So here the slope is negative 1 over 1, and the b is 2. So let's change colors. So we're going to go up 2, then down 1, right 1, down 1, right 1, and I'm going to go all the way across the slide. All right. So it was solid or dashed. Oh, this one was dashed. I need a different line because it's a dashed line, not a solid. So let's pick a different line. Let's go with that one. Having a little trouble with the line function. There we go. That's better. All right, and then the last thing to do is test the origin. So for the dotted line, the origin's on this side. So I can get rid of this true because I'm retesting for the other one. I'm checking to see if 0 is on the true side. So I put it in there. 0 is less than 2 because this always cancels. That's true. So again, the origin is on the true side. So we'll use blue this time, and the origin's right here, which means it's true. So I'm going to shade this side. And I shade the whole thing, the whole side. So you can see that there's double shading right here in the green part. So the graph is the actual answer. There's nothing to submit like a one particular point because it's all these points that's in the answer. So it's this one and 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 this one. It's everything over here as part of the solution. It has to have a double shading to be a part of the solution. So just the yellow and just the blue and just the white are not part of the solution. Okay, so we're taking what we did in chapter 6 and we're doing it 2 times on the same graph and then looking to see where the shading overlaps. Where the shading overlaps is the answer. All right, let's try another one. So number 3, y is greater than or equal to x minus 2. So my slope is 1 over 1 and my b is negative 2. So I'm going to go down 2 and put a dot, up 1, right 1. And this is a solid line. So I'm going to draw a solid line. Oh, I missed. Close enough. And then I'm going to check for this is solid because it's got the equal to. And then the shading. So I'm testing the 0, 0 right here to see if it's true or false. 0 is greater than or equal to -2. That's true. So again, I shade the side that has the origin because that's the true side. So I'm shading over here. And I shade the whole thing. All right, now I do the other one. I'm going to switch colors. So we'll do green this time. So my slope is 1/3 and my b is -2. Up 1 right 3, up 1 right 3, and this is a dotted line. So this time I'm just going to dot it instead of using the calculator function. And I'm testing the origin again with a completely different color. So 0 is less than -2. 0 is not smaller than a negative number. That 0, 0 is false. So I'm going to shade on the other side. So I'm shading below it. So that means anything in this little green area is part of the solution. And again, the answer is your graph. All right, one more. All right, solve the system of inequalities. So this is a horizontal line. I know that because if I make a little table for x and y, it says y is always 3. So I put some 3's in for y and some random numbers in for x. It is a dotted line or a dashed line because it does not have an equal to. So it's dashed. And then the shading. 0, 0 is right here, so I plug in 0. 0 is less than 3. That's true. 0 is less than 3. So we're going to shade below it. Right, and I'm going to do the other one. Let's switch colors so we can see a difference. So my slope here is -2/1, and my b is -4. So I go down 4, put my dot, and then down 2, right 1, or I can also go up 2, left 1. I'm going to go clear across the graph, and it is also a dashed line. All right, and then let's check the origin. The origin's right here. We're trying to decide if it's true or false for this line. So it was dashed because there was no equals. 0 is greater than -4. That's true. So I'm going to shade, let's use blue, the side with the origin because the origin makes it true. So I'm shading over here. And I have to do it all the way down. So everywhere that there's green and blue shading is the solution set. Where there's just blue, just green, or just white is not part of the solution set. Okay, so actually we're not doing a worksheet. You're going to go to Big Ideas now and try those problems first and see how that goes for you. So again, we were just graphing systems of inequalities on a coordinate plane.